Hi everyone, my name is Nikhil Deka and I am currently a third year undergraduate at IIT Guwahati. So today I am presenting my time project titled Intelligent Content Analyzer. It's a modular pipeline for I can say dynamic web scraping and semantic indexing. So the motivation behind this project is that many random modern websites really heavy on JavaScript to render their content, so making them difficult to scrape using traditional HTML parser such as BS4. So my objective was to build a modular pipeline that can reliably extract meaningful keywords from this dynamically rendered web page using the playwright module and transformer based natural language processing technique just like React, TF-IDF and some large language model. So additionally I incorporated a FAISS, so Facebook AI similarities as best vector indexing there to organize the extracted page profiles, provide a foundation for future semantic retrieval. So in this presentation I will briefly explain the problem statement, the tool stack and technologies, demonstrate the implementation and code, walk through, discuss the result, and conclude with key learnings. So let's get started in my computer. As you can see, I have a requirement.txt. So here I am giving the text set like Python as my programming language, fast API for the backend services, Ubicon to run the fast API server, keyword to for the keyword extraction from the websites, scikit-learn library, playwright, just it's a dynamic web scraping, so I use playwright. So in rack analytical, so rack everyone know rapid automatic keyword extraction. So it's specifically made for keyword extraction task. So transformers, FAIR CPU, Facebook AI similarity search, analytical library, Streamlight for the front end. So request module, RE, and beautiful show. This is for the parsing HTML text. So after that, for the let's talk about the dataset. So for the dataset, there is nothing such kind of dataset like unlike traditional machine learning project. This project does not rely on a fixed dataset. Instead, I created a collection of approx. So 50 JavaScript heavy web pages, including some e-commerce website like Flipkart, Myntra, etc., etc. And this website acted as an evaluation dataset. So for pre-processing, HTML boilerplate such as navigation menu scripts, advertisements, and styling elements were removed to isolate the meaningful textual context before keyword extraction and semantic indexing. So let's go through the code. So for first time, I am showing let's say processor. So this is the processor module. So using regex module and BS4. So text processor. So init function clean HTML. This part will clean the HTML part of websites. So remove noises and target content will be filtered. So then parse text, simple parsing, split the sentences using this many of Egan's notation. Will filter out the sentences. So after that, extract order type. Let's show you. So extract keywords. So using the LLM text generation, text to text generation, and Google Plan T5 small. So it's in lighter model and it's completely free. So I am using that. So extract keyword using this function. So extract keyword, then extract using array, then extract using TF-IDF, true frequency, inverse documented frequency, then extract LLM keyword. So here I am writing the prompt instruction list 5 important keywords from the text below. Focus on companies, people, technology, format keyword 1, keyword 2, keyword 3, keyword 4, keyword 5. So this is the strict instruction that will be given by the LLM as an output. So raw output will be generated text and simply split and clean. And final filtration, remove generic Wikipedia words like Wikipedia content sidebar, menu, articles, etc., etc. So after that, let's show you the embedding part, not embedding, database part. So SQLite, though it's a side part. So for the heaviness of the project, I am using Facebook AI similar pieces. So here we need some sort of I can say table. So initialize the table, insert and fetch by ID. So this is the part. So after that, we have scraper.py. So here I am using Playwright. So assuming Playwright like a dynamic web scraper, like DS4 sees just the HTML text, but the websites that are JavaScript heavy, that will be not scraped directly by the BS4 menu. So I'm using Playwright. So it basically renders the entire website, scan it, and extend the important info for the LLM. So after that asynchronous function, async def scrap test. So after that, give it more time and reduce the wait condition. So we'll extract the I can say from 30,000 first 30,000 content. So the I can say trending words will be inside the 30,000 sentence. I know, and I imagine that document loaded. Wait until document loaded. Complete documents I will be know. Then time multi-dot expectation as E, raise expectation. So factor store, here I am using Facebook AI similar as I have told you. So we have got mkdir, load indexes, load the entire metadata, and then save keywords into the, I can say Facebook AI similarity search. Save both page.rate index, indexing also given, and similarity search. Here I am giving similarity search concept. So query vector, save the model and etc. Everything is there. So I'm showing you the front end. So after streamline deployment, internal site keyword extractor, here we will be given, I can say, the website, then auto selected keyword, just it's an default. You can choose some sort of models like I'm giving EFIDF, rec, etc., LLM, etc. Then extract keyword, I will click here. After that, those keyword will be extracted directly. So after that, this is the function. You can see first the page server, playwright, clean HTML, clean the parse text using BS4, then keyword extractor inject this is, then factor store in Facebook async letters, we will store it, then giving output as on JSON. After that, here is app.py. So I'm using backend host. You can see here. So I'm using Streamlit. So now come the most important part, evaluation. So I evaluated the entire pipeline on a collection of JavaScript API pages, including e-commerce and corporate websites. So the evaluation was primarily qualitative when I manually verified whether the extracted code exactly matching in the exact, I can say, uh, the web page, or I am checking that my LLM is not hallucinating. So overall, the pipeline consistently extracted meaningful keywords from dynamically rendered pages, where traditional static scraping techniques would struggle. So in addition to keyword extraction, I am also implemented a Facebook AI similarity search based indexing in the layer. So although it's not the essential for the keyword extraction part, so it provides a foundation for the organization. Previously processed web pages and store those keywords and give the semantics as I told you in previous slide. If I'm searching for some sort of word like artificial intelligence, so my system is not enough to give those words also, which contains words like machine learning and deep learning. So that kind of task. So as future works, I am planning to integrate a large language model so that instead of returning only keywords, the system can automatically generate, summarize, and answer questions about index web pages and support more intelligent semantic searches. So I would like to improve the ranking of extracted keywords and extend the pipeline to process the larger collection of web pages. And at last, special thank you to the mentor, Arshit Agarwal, who is currently a lead developer at Oracle. So he helped me throughout the project. So to conclude, this project gave me hands-on experience in browser automation, natural language processing, transformers, and factor embedding solution. It demands how modern dynamic web pages can be processed effectively using Playwright and transformer-based natural language processing while keeping the architecture extensible for design and management. So this was the entire project. So I will have to answer any kind of question from this project. Thank you everyone.